Hello everyone, welcome to your favorite algorithm channel. Today we're going to be doing LeetCode 15, threesome. Let's introduce the problem. Given an array nums of n integers, are there elements a, b, c in nums such that a plus b plus c equals 0? Find all unique triplets in the array which gives the sum of 0. So a little note here, the solution set must not contain duplicate triplets. Here's a little example. So -1, 0, 1, 2, -1, and 4 should give a solution set that contains -1, 0, and 1, and -1, -1, and 2. So if you examine this array of nums closely, you'll see that it would be possible to return -1, 0, and 1 twice because we have two -1s here. But since we can't have any duplicate values, we can't do that. So we should only return -1, 0, 1 one time. So truth and honesty time. These kind of problems are not my favorite. Managing a lot of pointers. You know, there's threesome. I'm sure at some point we'll be doing foursome and maybe fivesome and sixsome and just have pointers all over the place. So not my favorite thing to do, but could be a little bit tricky just to kind of debug it when you're managing all those pointers. But we're up to the task. So as always, I encourage you to do the problem on your own first, and then when you have an answer and you're ready to maybe see how I did it or check what you did, or maybe you get stuck, come and check out the rest of the video. All right, let's get started. To solve this problem, we're going to use ratcheting. So we've used ratcheting before in another problem. We used ratcheting to solve container with most water. We're going to use the same strategy here. So what we're going to do is we're going to iterate through this entire array. And at each one of these numbers, what we're going to do is we're going to ratchet through all the numbers to the right of that number, right? So we're going to search this space and look for all the combinations with -3 that could possibly equal 0. And the strategy for ratcheting through this problem is if we look at our first triplet here, it's -3, -2, and 3. And that is a sum of -2, which is below 0. So we need our number to go up, right? So we need to increase our starting pointer, which will raise our number. And if the sum of our triplets is above 0, then we need to decrement the ending pointer because we need our number to go down. And by ratcheting our way through each one of these indices, we can find all possible triplets that equate to 0. Now, one thing that I also need to mention is that our array here is in sorted order. So the first step of solving this problem is sorting the array of input numbers. So we'll sort the array of input numbers, and then at each index we're going to ratchet our way through all the numbers on the right, searching for all the possible triplets. So let's go through a iteration of solving this problem and just see how the algorithm will work. So our first triplet here is -3, -2, and 3. So that's a sum of -2. So we'll increase our starting pointer. So our next triplet is -3, -1, and 3. That's a sum of -1. So again, we'll increase our starting pointer. So now we're at -3, 0, and 3. That's a sum of 0. So we'll record that triplet. And now here, our sum is 0. So we need to actually both increment our starting pointer and decrement our ending pointer. And the reason why we need to do both is because since the pointers are on numbers that currently equal 0, if we move one of them, it will not equal 0 because we're either going to be increasing or decreasing the number. So what we need to do is move both pointers at the same time. And then check again for our next number. So we have -3, and then here we have 1 and 2. So that's a sum of 0. So we'll record that triplet. And now you can see that our pointers here are have met each other in the middle. And since our pointers have met each other in the middle, we need to now increment our the number we're checking from. So now we'll increment to -2, and we'll reset our pointers. So now we're at -2, -1, and 3. So that's a sum of 0. So we'll record that triplet. And we'll move both pointers. So now we're at -2, 0, and 2. So that equals 0. So we'll record that triplet. And we'll move both pointers. So now our pointers have met in the middle. So we can increment the number we're checking from and reset our pointers. So now we're at -1. Now we're at -1, 0, and 3. So that's a sum of 2. So we'll decrement our ending pointer. And now we're at -1, 0, and 2, sum of 1. So again, we'll decrement. And now we're at -1, 0, and 1. So that equals 0. So we'll record that triplet. And our pointers have met in the middle. So we'll reset our pointers. And check for all possibilities with 0. So this current triplet is 0, 1, and 3, which is sum of 4. So we'll decrement. And now we're at 0, 1, and 2, which is sum of 3. Our pointers have met in the middle, so we'll reset. So now our first position is at 1. And because our position is at 1, we cannot possibly have a number that is 0, right? Because our smallest number in the triplet is going to be this number here, the first position. And since it's above 0, we don't have to continue checking, so we're done. So using this method of ratcheting, we have found all the possibilities of 0. And by kind of ratcheting our way through all these values and then and checking all of its values to the right, all the possibilities to the right, we found all the possible triplets. So now what I want to do is let's just talk about how we're going to deal with duplicates and potential edge cases in this problem. I've gone ahead and drawn an array here that has a bunch of duplicates in it. So let's just run through this problem and talk about how we're going to deal with the duplicates. So our first position here, our triplets -2, -2, and +2. That's a sum of -2. So what we need to do is increment the starting pointer. And we could increment it here to this -2, but we've already checked -2, -2, and 2. So there's no need for us to check it again. So we can move that all the way up to -1 and just skip all of the duplicate numbers. So what's the sum here? So this is -2, -1, and +2. That's -1. So again, we can just bypass all these other -1s and just move it to 0. So now we're at -2, 0, and 2. That's a sum of 0. So we'll record that triplet. And we need to move both pointers. So we'll bypass all of the other zeros and we'll move this to 1. And we'll decrement our ending pointer, bypassing all of the 2's and move that to 1 as well. So that's -2, 1, and 1. That's a sum of 0. So we'll record that triplet. And we'll increment start and decrement the end. Our pointers have passed each other. So we can increment the start And again, we're in a position here where we would normally just move it to -2, right? And we don't want to do that, right? Because we've already checked all possibilities with our first number being -2. And you might ask, well, what about the case where, what if we just started from here, right? Because now we're checking a -2 with where the second number here would then be -1, and we'd be ratcheting from that point. And what I'll tell you is that we don't need to do that again, because when we were ratcheting through on this first -2 here, we eventually checked this value right here, this -2, this -2, -1, and 2, right? So we don't need to do that again. We don't need to check any possibilities with -2. So we can actually just move that. We can move that number. We can just move it straight up to -1 and reset our pointers. So now we have a sum of -1, -1, and 2, which is 0. So we'll record that. And we'll move both our starting pointer up to 0, and we'll move our ending pointer to 1. So now we're at -1, 0, and 1. That's also 0. So we'll record that. And we'll increment the start and decrement the end. And our pointers have passed each other. So we'll move up to 0, and we'll reset our pointers. So now we're at 0, 0, and 2, which is a sum of 2. So we're too high. So we'll bypass all the 2's, decrementing our ending pointer to the next number, which is 1. And now we're at 0, 0, and 1, which is a sum of 1. So again, we're too high. So we'll decrement our ending pointer to the next number, which is 0. And now we're at triple zeros, which is a sum of 0. And we can record that. And now we'll move our pointers, bypassing all the other zeros. And now you can see that we're done, right? Because the minimum value of our triplets is above 0 now. So there's no need to keep looking. So we found all the available triplets where the sum can be 0. So let's talk about the time complexity of this problem. So what are we doing? Well, we're iterating through this array one time, right? So that's going to be n. And then at each iteration, we're ratcheting through the rest of the array. So at this position, we checked all of these values, and then from this position, we checked all of these values, and then from this position, we checked all of these values. So at each loop, we're looping again by some factor of n, which is going to make our time complexity equal to big O of n squared, right? But one thing that I should mention also is that when we started out, before we started this array, we don't have a sorted array, right? So we can't just assume that it's sorted. So the first thing we need to do is we need to sort it. So that's going to be n log n. Sorting is n log n. So that's going to be n log n plus big O of n squared for the time complexity. But because n log n is not going to affect the upper bound of the time complexity of this problem, we can just ignore it, and we can just say that it's order, or it's big O of n squared. And the space complexity, well, we're not using any extra space here, so space is constant. So now that we know how to solve this problem, let's see how to solve it in code. To solve this problem, we're going to use two functions. We're going to use, of course, 3sum function to house all the logic for solving the problem. or coding out the algorithm. And then we're also going to have this move index function. And what move index is going to do is just going to look at, okay, what's the current number, and move our index to the next available number in the array. So let's code this this helper function first. So we'll just say that while the current value equals the array index, then we'll just say, okay, if we're decrementing, so I've added this fourth argument here that we just pass true or false to, or undefined. We don't define it. So if this is defined, if it's truthy, then we're going to decrement. So we can just say index minus minus, and then otherwise we want to increment. And that's just because that way we can use the same function for both the starting pointer and the ending pointer. We don't have to have two functions that basically do the same thing. And then we'll return the index at the end. So this will just be nice because we won't have to have these while loops all throughout our function, just to make it a little bit cleaner. And then what we'll want to do is we'll want to create an array to keep all of our sums. And then we will initialize a pointer I to 0. That's just going to be the current part of the current index in the array where we are searching for all the possible triplets. And then, of course, we want to, the first thing we need to do is sort the array, right? So we'll call sort on the array, passing in the two values, and we'll just return A minus B. So that will sort the array in ascending order, which is what we want. And then we can start the loop, right? So if I is less than the array length minus 2, and we're doing minus 2 here because we have 3 pointers, right? So we don't need to go all the way to the end of the array because our 2 pointers will take those 2 spaces. So we just need to go to the end of the array length minus 2. And so then we need 2 pointers here as well. So we'll create a starting pointer. So the starting pointer is going to be equal to the current position plus 1, and then an ending pointer. So the ending pointer is just going to be equal to the last index in the array. And then we can just do some bound checking. So we can just say that if the array at I is greater than 0, or the array at end, if that's less than 0, then we can just break out of the loop, because if our starting pointer is greater than 0, we're not going to find any sums that equal 0. And if our ending pointer is, likewise, if our ending pointer is less than 0, we're also not going to find any values that are equal to 0. So now we can start looping. So we can start rationing through the array. So we'll just say that while the start is less than the end, then we want to keep searching. So we'll first collect our sum. Our sum is just going to be equal to the array I plus the starting index plus the ending index. And we'll just check to see, okay, if our sum is equal to 0, then we want to push that triplet into our sums array. So that would be, the index at I, start, and end. And since we have found a triplet that is 0, we now want to reset our starting pointer. So we'll call move index, and we'll pass in the start, the array, the current value, and we'll do the same thing for the end. And also for the end, we want to pass in that true for the decrementer, so that we will decrement our value instead of incrementing it. And if we have not found 0, then if our sum is if it's greater than 0, then we want to decrement the ending pointer. Otherwise, we want to increment the start. So this takes care of all the logic for ratcheting through the array. And now what we want to do is just return. So now we need to reset I, right? So we need to reset that point where we're checking for all possible triplets. And what we want to do is we want to move I to the next available number. So we'll call move index on I, passing in the array and the current value. And then at the end, we just want to return, the sums array. So let's do a little recap of what we did here. So we created this helper function move index, which just takes our current position, what's the value at that current position, and just moves us to the next available number. And then for threesome, we initialize this array of sums to keep all of our triplets in, and a pointer to track our position in the array. We sorted the array in ascending order so that we could actually use ratcheting to search through the array for the triplets. And so then we're looping through, and we create a start and end pointer. We just check to see if our current search space allows us to actually find something that could potentially be 0. And then we start ratcheting here. We collect our sum, and then if our sum is 0, we'll push that triplet into our sums array, and then we'll move our starting index and our ending index to the next number, so bypassing all duplicates. If that's not the case, then if our sum is greater than 0, then we'll decrement the end. And if the sum is less than 0, then we'll increment the start. And then we'll move I to the next available number after we're done ratcheting, and return the sums at the end. Okay, great. So let's take a look at some of the results. All right, so we finished in the about 75th percentile, which is good. And like I've said in previous videos, take this stuff with a grain of salt. I think it will tell you if you have created a really crappy algorithm, but it won't necessarily tell you if you've written the best algorithm. If I'm in this range, I generally feel pretty good that I have probably created an optimal solution to this problem. Anyway, I hope you enjoyed this video. I hope you learned something, and I hope to see you in the next one.